question 4, and there's really sometimes I think I should practice these questions before I push play on the video. Right, so minus 12i, that is 12 e to the minus pi over 2, isn't it? So because it's straight down, so that's the original one there. But we could add 2 pi times by n there, going round and round. And we want to find the fourth roots of that, so we're doing that to the power of a quarter. So 12 square root, fourth root of 12 here, the fourth root of 12, and then we're going to have e to the minus pi over 8 plus a quarter of that, so that's a half pi n. So when n is equal to 0, we've got the fourth root of 12 e to the minus pi over 8. When n is equal to 1, we would then have the fourth root of 12 e to the adding half to that, so that's 3 pi. I've missed my I out. I always miss my i's out. 3 pi over 8i. When n is equal to 2, we'd have the fourth root of 12 e to the 7 pi over 8i. And if we go any further, that's going to be too big, so we'll go to minus 1, minus 1. So we've got the fourth root of 12 e to the minus 5 pi over 8i. So there's 6 marks. Take that. There's my 4 cube root, my 4 roots of that. And where are they? So at minus pi, so that one's down there at minus pi over 8, and that one, the next one's up here. So we'll call, taking in order of increasing theta. So that's A, B's there, C's here, and D's here. And we know, what are we doing then? We're then trying to put something on here. The midpoint of this side here. So that midpoint here is going to be x. That distance there to there is going to need to be found out. I'm going to have to pause and think about this. Right, well, it's taken some thinking, but I've got it. I'm perfectly happy to find out what this angle here was. I'm not really worried about that because remember, this argument of this one here was minus pi over 8, and this one here was 3 pi over 8 up there. So this one's just in the middle of them. So that argument there is simply just pi over 8. But I was then worried about how long this was, but it is just a little bit of trigonometry. So look. This triangle here, I'm just rewriting because it is a right angle triangle. We know that that length there is the fourth root of 12, and we know that that angle there is just pi over 4 from this part here. So this distance that we were trying to find out, which is this distance here, is just 4 pi over 12, sorry, the fourth root of 12 times the cos of a quarter pi. Now the cos of quarter pi is root 2 over 2, and we've got the fourth root of 12 of all of this. So and then I'll just plan about with this as well. And so I'm thinking that rather than writing this as the square root of 2, we could write that as the fourth root of 4, just squaring it, and that 2 on the bottom, we could write that as the fourth root of 16. So now I've got just fourth roots and all of this. I've got 48 over 16, which is 3. So I've got the fourth root of 3 here. So this part here is the fourth root of 3 e to the pi over 8i. Pi over 8 because that's the angle there. Now, all of the other ones are just going to be the midpoints of all these other ones here. So all we're going to do now is, so that's the first point, is I'm now just going to times each of these by e to the pi over 2 to rotate it round. So it's going to give me the 4th root of 3 e to the 5 pi over 8I. That's that one. The next one there is going to be too big, isn't it? So we'll have to take it away that time then. So that would be minus 3 pi over 8, and take another half pi as well. The cube root of the 4th root of 3 e to the minus 7 pi over 8. I think they are my 4 new ones there. But reading the question, I didn't need to do all of that, did I? I wasn't asked to do all of that. It was asked to say, so if this was one of the roots, what is the original one there? So we've just got to do that to the power of 4. We're doing that to the power of 4 gives us 3 e to the times that by 4 gives us pi over 2I. Pi over 2I is straight up, isn't it? So this gives us 3I. 6 minutes 15 plus the stop to think about it. Not doing that again.